Hello friends, welcome back to the bench. Today we have a Surface Pro 5 model 1796. So it's a next generation as opposed to the Surface Pro 4, which we normally work on. And this one, what's wrong with this one? Other than the cracked screen obviously, and I already took the screen out to save some time, the SSD is not being detected by the computer. So the computer goes directly to BIOS. There's no BIOS lock, so that's good. On Surface Pro 4, when I have a case like that, I just take the NVMe, I take it out, I replace it, perhaps fix this one, and everything's good. On this one, on the other hand, it's very different. It's only one generation, but there's plenty of changes. So, number one is we have fanless heatsink. There is no fan. And the reason there is no fan is because our CPU is so much smaller, so much more efficient. To compare, this is the CPU from Surface Pro 4, this is Surface Pro 5. 4, 5. So we don't need the fan because it stays cool, and actually when I turn it on and it goes to BIOS without the heatsink, it heats up to only about 48 degrees, something like that. It would obviously go up if it booted to Windows, especially when the GT voltage, VCC GT comes on. I assume that powers the GPU. The resistance on the V core, which is this one, is 15 ohms and about 6 ohms on GT. So a lot lower, a lot higher resistance than on the Surface Pro 4, and I expect the voltage, it's 1 volt on Surface Pro 4, I expect about 850 millivolts on this CPU. So it's a lot more efficient, it doesn't heat up, it's still, as you can see, it still has the bay over here where the fan goes, it still has the ventilation, so the frame is pretty much the same as Surface Pro 4, and it looks like they just, they just left this area unoccupied where the fan would be. I do have a board view, however the board view has plenty of nets unlabeled, so I don't know what they are, which makes it very difficult. It's better than nothing, but it's very close to nothing. I have no schematic, so it's really difficult to work with this without the schematic. So it's going to take me a while to understand the full architecture of this board, but where I started was to find the EC chip, right? Check the EC power and go from there. See how the 3.3 or 1.8 for the EC chip is generated. I checked that circuit and all that stuff. But I concluded that this board doesn't have an EC chip separately. The EC is over here along with PCH. On Surface Pro 4, PCH is in this package, but EC chip is separate. This one has both EC and PCH in this package, and so the only external component is a SAM chip. And SAM, unfortunately, is roughly around here behind the board, on the other side of the board. So that's pretty unfortunate, because that is something when the computer doesn't power on, you want to check that early circuit, that standby circuitry. And SAM is going to be one of the things that you need to check, because that's going to be the chip that talks to the battery. If there's anything wrong with that, computer will not charge and likely will not even start booting. Here we have a TPM, It's in a different spot here. Doesn't have a separate dedicated bay for itself. Here we have a BIOS chip, the BIOS debug socket for the debug chip, the same as on Surface Pro 4. And this is 5, was it? No, let me check that so I don't give you wrong information. This one is, yes, so this is 5-volt standby. The next one let's see, under this one, this is 3P3. So this is the equivalent of this one. It even is the same coil, right? So this is our first voltage that supplies EC, and we have the same one over here, and likely even the same chip over here. I can't see it right here right now, and obviously without the schematic we're never sure, because the markings on those chip can be misleading. This coil is this one, 1-volt standby, so this will also be always present. And the last coil is our backlight, surprisingly enough. This is our backlight, and it goes to the connector for the screen, and likely controlled by this chip. Let's see. Yep. So this chip produces the backlight voltage with this coil. And that's pretty much it. That's all I know about the board. The VCore VCC GT. The memory, or 1.2, it's even in the same place. It's kind of built the same way here. This circuit looks exactly the same. Same chip, same coil. Even the positioning is pretty much the same. So this is a close modification of the original board. Now the worst part of this is that this is our SSD. We have 2 slots, 2 places where we put 2 chips. This is 128, and we can put another 128, making it 256. As you can see, this is soldered on. It's not glued on, which is good. If it was glued on, it's a little harder. We have 2 coils over here and 2 chips that produce voltage for SSD. And we have, this is 1.1 volt, this is 1.8 volt. And we have 1 more coil over here, which produces 3.3 volts also for SSD. So we got 3 voltages that go to SSD. On this computer, we don't have SSD, or the SSD is not visible to the system. So the first thing that we need to check is whether the SSD gets its power, and if it's good, right? So for that, the computer needs to turn on, and this is actually a great thing about this one, because we don't have to put the heatsink on it to turn it on, because it's not going to burn. The Surface Pro 4, if you don't put this heatsink, the CPU will fry. You can disconnect the fan. It won't burn, but if you leave it without the heatsink, it'll just fry up. So, having all that knowledge, let's connect it. It charges with full current, 24 watts. Right, so our charging circuit is fine. Let's check some voltages that I haven't checked before. Our VSys, eight volts. So the battery is dead. it's fully discharged. Okay, so I don't know that much about this board yet, so there's certain guesswork that goes into it. Now, it is not turned on now, so there's not going to be any voltages here. Yeah, this is all 0, because we are in the state where we don't need this power, right? So let's turn it on and check the voltages on SSD. So this should be 1.1 and it is 1.104. This should be 1.8. It's 1.796. 4 millivolts low. That's not low enough to think that there is a short. And we should have 3.3 here. Excellent. And 3.3 here. Excellent. So we have all the voltages that we need. Let's check what is the vCore voltage. Is it 850 or is it 1 volt? Yeah, it's 800, not even. Well, it fluctuates, yeah. 1 volt to, yeah. This will fluctuate depending on how much power the CPU needs. CPU is barely warm. It's heating up, but it's barely warm. So what's our next step? Let's turn it off first. Let's get the heatsink out of the way and let's turn it off. So I'm just gonna monitor for vCore and hold the button until vCore goes away. There. Now we're off. So the next thing that we can do, because we do have voltages that are supposedly going to the SSD, but do they actually make it to the SSD? Because maybe we have voltages, but the connection to the SSD is broken. So let's see if SSD is heating up. SSD will be heating up as it works. All right, that's why the SSD usually comes with a little heatsink, because they do heat up. So if it's powered, we want to see the SSD lighting up under a thermal camera. So our coil is a little warm. Oops, let's go to the full view. There. Alright, our coil seems a little hot, which is fine. It's got, oh, yeah, the, what do you call it? The MOSFET and the coil, because it's pulling, 24 watts. So yeah, it's gonna be hot. But our SSD is here. So let's see what happens when we turn it on. The top is much less heating up than the bottom of it. But the bottom takes 3.3 and the top takes 1.8 or whatever. We are at 40 degrees. So first, we can conclude that the SSD chip definitely receives power. It is heating up, 41.2. It is a little warm for my taste. But, if it went up to 70, 80 degrees, that would definitely be shorted. But I don't think it is shorted. And it definitely receives power. Now, this computer has been dropped. So what we could expect here are the issues with you know, broken solder, that kind of stuff. Why is it not turning on? Let me check that with the on the V-core. Yeah, it's still on. Oh, let's shut it down. There. All right, that is shut down. So we know that the SSD is powered. We know the voltages are all good. What is the final thing that we can do? Well, there's few things we could do from here. We could replace the SSD. Well, it's not gonna be easy, and I don't have a donor at this point. Or I could just maybe order it from China. I'm sure this is available in China. Maybe it even comes with a stencil. But I have none of that. So the only way that I can oh, actually there is one more thing that we can check. Other than the voltage, we could check for a clock signal. But the problem with the clock signal is, let's find the clock over here. Come on, where are you? SSD clock, SMB clock, and data, but that's not what we want. Oh crap, I can't find it now. See, always when I'm recording, something goes. I did check it before. It's usually called extal. And that's probably what it was called, extal, here, in and out. And the problem with that is, you can see that on the other side of the board, we have a crystal, and it only connects here. So there's not like a resistor or capacitor that we can check on this side. So to check the clock, we need to dig the board out, flip it, and check the crystal over here on the other side. And also, yeah, we can't even really check it because there's no test point. Yeah, but there's resistor over here, so we could check on this resistor. Okay, and it goes to out. So this is something that we can check in addition, because if there's no clock signal, obviously this will not work. And this is Surface Pro 4. But to do that, I would have to clean the frame, because obviously the screen came in pieces. It was completely shattered on both sides over here. This has been dropped multiple times. So there's only one thing that I can do at this point, and that is reflow the SSD. SSD is a big chip, and the board will be flexing a bit, especially when it's dropped. The SSD can suffer from issues where basically the one of the pins becomes detached. There's not too many of these that we need over here for this chip to work. There's like literally just few connections that we need to make. And for that reason, if only one of those is missing, the whole chip doesn't work. There's no redundancy on these. So let's get the temperature to 400 degrees and a full blast. I will actually probably take off the nozzle or put the bigger one. Maybe I'll just put the bigger one. But first, let's do this. Let's cover the connector, because I'm going to be blasting with a lot of heat here. So I don't want to damage this connector here. As it would likely melt. Oh, actually, I should be able to just put the screen on it. But that's fine. The rest, yeah, this still has shields on it, so this should be fine. And I'm gonna be blowing from this side to this side, so all of this is gonna start floating on the board. Let's get the biggest nozzle we have. I gotta remove the nozzle and try again, because the solder is already melting on the shields, but the chip still won't loosen up. So let's get rid of the nozzle and try this again. Whew, that required nozzle off, full blast, and full power, 500 degrees. I was trying on 440, nothing. On 380, nothing. 440, nothing. Finally on 500, it managed to dislodge it. Well, it is reflown. Whoa. Probably should have put something on the battery to protect it from all that heat, because the battery is red hot. Whoa, I can't even touch it, it's so hot. I risked explosion. Let's get it outside for a second maybe, or by the window. Well, it's not, it's pretty hot. This is Georgia, summertime. So it's not warm, it's not colder outside than inside. I don't have those cooling pods. That would be a good thing here. Oh, the whole machine is red hot. But that's what it takes to reflow the memory chip. Now you see the difference between Surface Pro 4 and 5, and repairability of Surface Pro 4 is much better. Well, much better in this case. because again I would just replace this little thing and the repair is done. On this one, I mean, if we detected that there's no 1.1 or 1.8 or 3.3, we can figure out what's going on, that we don't have that voltage. But if it gets all the voltages, and suppose we checked the crystal, the clock signal, and the clock signal is there as well, well, yeah, the only thing is to replace the SSD. But the question is, can you replace an SSD on this machine without any problems, right? Is it like in Macs, like you replace one chip and the serial number is different, so half your functionality doesn't work anymore? Or we can just replace it just like we did on Surface Pro 4 by replacing the module. Eventually we will get an answer to that. Okay, the battery is still pretty hot. The battery took the most hit. I'm not sure. Yeah, actually, you know what, for the memory reflow, definitely don't do it the way I did it, because I took a big risk, because the battery, just touching it, you know, over 60-70 degrees, because I couldn't even touch it, it's so hot. It's not good for the battery to heat up that much. First of all, it could bulge up, it could start burning, exploding, whatever. The battery life might be reduced dramatically because of that. And so what I should have done is take the board out of the case, away from the battery, and do it on the bench. That probably also would have been easier because there is no case to take that heat away when I was heating up the chip. So something to remember for the next time. Okay, it is now cooled down. The battery is slightly warm, it's fine. Our chip still seems aligned. So let's see what happens now. But I don't know if our screen still works. So the screen, as you can see, the majority of that screen is left over here. So let's see what's gonna happen. I'm probably not even gonna connect a digitizer. It did work, but it probably, after the removal, it won't work. That would be my guess. And we'll see if it even displays anything after the removal. Because I had to rip it, you know, to just save up some time. Because at this point, you know, with this amount of cracking, it's it doesn't matter what you do, you're still gonna have sharp pieces of glass everywhere. And yes, I cut myself, and ironically, I cut my foot. Working on this, I cut my foot. Can you imagine? How did I do that? Well, the piece of glass fell on the ground and I stepped on it. Easy explanation, but yeah, you can cut your foot by working on Surface Pro 5. Okay, it is still charging with full current. Now let's see. Oh, it works. But now let's see if it's going to detect the SSD. And I can tell already that it did not, because the logo started blinking. So it's, yep, the logo is blinking. That's what happens when the SSD is not detected. Yeah, can't find bootable operating system. Yeah. Oh, the touchscreen still works. Nice. So that little symbol over here, that means the SSD is not detected. So at this point, zero touch Wi-Fi management ready. If your setting manager has provided a configuration file on USB, press install from USB to apply management file. I'm not sure what that is, but I guess this is when it's kind of cloud managed. computer, then you just install some crap from USB, and you can manage the computer remotely. That's usually what you will find in corporations. But the reflow did not help. So our conclusion at this point is that the SSD itself is faulty. My next step will be probably to dig the board out, because this is too bad, because other than that the whole computer works perfectly. It just doesn't have an SSD. I could boot it from USB and it would probably work. The Surface Pro 5 doesn't come with USB-C, unfortunately. I think, well, 7 definitely comes with it, but I'm not sure about 6. I haven't seen 6 yet. But it would have been easier problem on 7, I guess, since we have USB-C and USB Type A, which means you can put whatever your storage by using USB-C and use this as a charger, this connector, because it has both, which is actually awesome. You can charge with USB-C, which actually charges with 20 volts, or you can charge with this connector, which charges with 15 volts. So this is way too bad. I was hoping the Surface Pro 5 would have been easier to repair, or at least similarly difficult to repair. I did not expect it to be even more difficult to repair. That's problem number 1. Problem number 2, access to schematics. I still don't have them, can't find them. If any of you guys have these schematics for Surface Pro 5 model 1796, definitely hit me up. I'll pay you if you want. That's not a problem. Because I'm dying to know how stuff works over here, and just based on the board view, it's very difficult. It takes a lot of actually it is helpful that I have good understanding of Surface Pro 4, because this board is similar in its architecture. So it definitely makes it easier having the schematics and board view for Surface Pro 4, but it's different enough that I would like to see it on the schematic, how it actually works. Plus, the schematic also gives you the block diagram, the power states, the power on sequence, so you can just follow which voltages should appear in which order, and you know which one which one is responsible for preventing the machine from booting. Well, I'm kind of disappointed, but this is the only one, because I bought a few of these, 9, but one of them turned out to be 1724. Not a problem. 256 version, no BIOS lock, SSD working, just needs a system reset. Obviously cracked screen, it needs new screen, no problem. And so only 8 of them are Surface Pro 5, and this is the only one that has issues with an SSD. That's why I picked this one as my first subject. The rest is just, take off the screen, put the new screen on, reset the system, and some of them are already reset. It's in the state where you're welcome to the new operating system, select the language and all that stuff. So some of them I don't even need to do anything regarding installing Windows. This one, if I can figure out the SSD, actually I will order an SSD from China and replace it. I will need to find a stencil, but there's not that many connections on it. I can probably just manually reball it and solder it on and see if that resolves the problem. If it doesn't, well, probably before I do that, because this time I won't be working on the board when it's inside the case, I will take the board out. So I will check the clock signal on the other side, on that resistor, but I'm pretty sure it will be there. I mean, the drop could have resulted in crystal being damaged. Crystals don't like to be dropped. But I don't know, based on my experience with these machines, they are pretty resistant to dropping. I mean, obviously screen will crack, will shatter, but everything inside usually is intact. But that's the problem of soldered-on SSDs. And I understand it might be, it is way cheaper, way easier to manufacture a device that you don't need the connector, you don't need to supply the separate component, separate module that you can put in and take out. So yeah, manufacture-wise, it's easier. But I wouldn't mind if this was even more expensive, because it is just as expensive as the Surface Pro 4. The similar prices, comparing the historical prices. So it's not even less expensive, and it's way less repairable when the SSDs are soldered on. So the only saving grace here will be if I replace the SSD and there are no problems. The computer doesn't complain that it's a different SSD. If that be the case, we're good. I mean, no, it's definitely a lot cheaper to replace the SSD on Surface Pro 4 than 5, but, well, you do what you gotta do, right? Well, that will be the plan. So far, my impression of Surface Pro 5 is meh. If at least the battery was disconnectable, that would have been awesome. The board is simpler, less components, fewer components, so that's good, usually. The SAM is on the other side of the board. Crappy, a very crappy solution, but especially since you saved up so much room on the board, you could have put SAM on the same side as the everything else. You don't have to put it on the other side, or at least I wouldn't expect it to be the case, right? So so that was, in my view, kind of a poor decision repair-wise, but the repairability is not necessarily the main goal of the designer. It's rather the engineering cost, or the manufacturing cost, and parts availability and all that stuff. So, I do believe that the last thing that the engineers designing this were thinking of was the repairability of it. Unfortunately, but that's the reality of this business. If this was easy, I wouldn't have a job, because you would be doing this yourself. Just like back in the day, you would just open the back cover of the phone, take the battery out, put the new battery in, put the back cover, and it's done. Now, you have to send the phone to me. I have to spend a few hours ungluing the battery and replacing it, if it's even possible, because on iPhone, that's not exactly it. That's not exactly something you can easily do. And again, you can, because as long as the battery circuitry is okay, you can just replace the cell itself, because the cell itself doesn't have any data and information. It's only that little chip that is on the battery, right? So if you just disconnect the cell and just replace the cell, you get new battery. I mean, new battery. The phone still says that, well, the battery needs replacement or something like that, but everything will work. That's relatively complex procedure, and it requires a spot welder. You can't really, I mean, I guess you could solder it on, but you shouldn't. Safety concern. So you need a spot welder to do that job, but it can be done. And again, that's why we, the repair technicians, have work. So it's kind of, we complain about tough repairability of stuff, but that also means that something that the user used to do by himself, herself, themselves, and now it has to be done by the technician with whole crap load of tools to do a simple battery swap or memory swap in this case, or a storage memory swap. Because the RAM, yeah, that's usually soldered on. I haven't seen a laptop or tablet created in the last decade that would have a removable memory. It used to be the thing. It's not a thing anymore. It's soldered on, but you know, usually with the RAM, usually what the computer comes in with, you're just stuck with, and that's the reality of it. But SSD, or basically the storage, that is something that you would like removed from your computer, even for the sake of security. When you're just done with the machine, yeah, you can reset it, you can do a lot of stuff, but back in the day you would just, you know, pull the memory, and here's the computer for recycling, and I'll keep the memory. Maybe I have something over there that I will need or whatever, just put it on the shelf and stay there, and maybe in a year I'll remember I had something that I needed, and yeah, there it is on my memory stick. So that was kind of a step in the wrong direction with putting the SSD on the board, in my view. And I know why they did it. I expect they did it because Apple does it, and a few other companies also started doing that. I don't think the Microsoft was first doing that, so they just kind of followed suit with other companies, which is too bad. But again, you know, appreciate the good parts of it. If the storage replacement was as easy as replacing this, then you wouldn't need me to do it. So yeah, appreciate the good stuff. But do complain. Don't get me wrong. Do complain about the right to repair, because the world is not going in the right direction when it comes to repairability and ownership of the device. That's the worst part of it, the ownership of the device. Alrighty, thank you, fellas. Didn't actually plan on the little rant over there, but thank you nevertheless. I hope you learned something about the Surface Pro 5. Don't give up on it yet. It's not a bad machine, and it's much quieter because no fan. It doesn't heat up as the Surface Pro 4 does. It's a good machine. It's a pretty good machine when it works. The displays are more expensive for these. That is unfortunate. But I got them in the price of maybe 16, 17 bucks a piece. So I can even turn around and just sell it for 30 individually. So I'm not gonna lose money on this, and I'm gonna learn a tons of stuff. Alrighty, fellas, thank you very much, and I shall see you guys in the next one.